Good day everyone. I would like to introduce this video, and this video is about our group assignment from course SEEE3533 Communication Principle. This video will give all of you some general knowledge and understanding about the Ericsson game Mission 4 that all of you are going to play. We are a group of students from section 5, and our group consists of member Anissa Sabila Erzil, Chai Bing Cheng, me myself, Nurul Safwana binti Muhammad Zin, and Tu Shen Yong, 4 members. Ericsson Game Mission 4 actually required some knowledge and understanding about radio digital modulation, RDM. Before get into detail what is RDM, we have to know a bit basic knowledge about what is amplitude modulation, AM. So, what is AM? Amplitude modulation is change in amplitude of the carrier according to the modulating signal. Modulating signal VMT, when passing through the AM modulator with the carrier signal VCT, the carrier signal will change its amplitude according to the modulating signal, and hence the amplitude modulated signal VAMT will be generated. Next, what is amplitude demodulation? Amplitude demodulation is the process that converts the VAMT modulated signal back to original modulating signal VMT. This method that normally will be used is envelope detector. Amplitude modulated signal will pass through the diode, low pass filter, then go to DC component blocker. After that, it will get back the original VMT signal, information signal. Here is some basic knowledge about angle modulation, which are phase modulation PM and frequency modulation FM. When modulating signal undergoes FM modulation, it will generate this kind of modulated FM signal. The positive peak of the modulating signal will make the generated FM signal has higher frequency. The negative peak will cause the FM signal will have the lower frequency. For phase modulation PM, the PM generated will have high frequency when the modulating signal is at the rising signal, and when the modulating signal is falling, hence the phase modulated signal will have lower frequency. Here is some of the idea and general equation on how to generate FM and PM. And here is some of the idea and general equation on how to demodulate the FM and PM signal to get back the modulating signal or information signal VMT. Therefore, we actually can see that the FM and PM signal are somehow related to each other. Previously, AM, FM, and PM are the modulation method that use analog as modulating signal. In radio digital modulation, RDM, we use 3 other techniques that use digital as modulating signal. There are 3 techniques that can be used. First is ASK, amplitude shift keying. Second is FSK, frequency shift keying. The third one is PSK, phase shift keying. Amplitude shift keying, ASK, is a form of amplitude modulation that the digital data and the modulating signal that change the amplitude form of a carrier's wave. Digital signal is used to switch the carrier amplitude low and high with its binary number 0 and 1 respectively. ASK, also called as on-off keying, OOF, and interrupted continuous wave RCW. This is roughly the idea on how we can generate the ASK signal. When the digital modulating signal is input into the modulator with the analog signal as carrier signal, then the analog carrier signal will change its amplitude according to the digital signal. Hence, the VASKT that produced will be look like this. Our VASKT is our ASK signal. This slide is about some of the methods that can use to generate the ASK signal and transmit to the receiver through suitable medium. The method to generate ASK signal, such as using multiplier, using on and off switch. At the receiver side, in order to get back the original signal, we use envelope detector and using the coherent detector to demodulate the VASK to get back our information signal or modulating signal VMT. Next, this is about frequency shift keying, FSK. Diagram here show how FFK signal can be generated. In order to generate FSK signal, we have to generate two ASK signal and then sum them up through the summing junction. Hence, we can get the FSK signal. One digital input will send into the modulator and going to the oscillator with frequency F1. And one of the signal will go into the inverter to generate another inverted signal and going through the oscillator with frequency F2. After that, the signal that produced with different frequencies will sum up together. Hence, we can get our FSK signal. This is about some of the methods that used to generate the FSK signal and transmit to the receiver through suitable medium. The method to generate FSK signal, such as using multiplier, switch, and VCO method. At the receiver side, in order to get back the original or modulating signal, we use asynchronous method as shown in here. FSK signal first detected by PLL, phase lock loop detector, then filtered by low pass filter. After passing through the voltage comparator, then we can get back our data signal. That is all from me. The next speaker will continue the explanation about radio digital modulation.
Now I will explain about phase shift keying. Phase shift keying, or PSK, is a digital modulation scheme based on changing or modulating the initial phase of a carrier signal. If you see here, when this signal is 1, this signal does not undergo phase shift. However, when this signal is 0, this signal is shifted 180 degrees. To generate a PSK signal, first, message signal will enter the low pass filter. Then, the output signal from the low pass filter and carrier signal will enter the mixer. As you can see, the output signal from the mixer is the PSK signal. To demodulate the PSK signal, coherent detector is used. First, the PSK signal and the carrier signal will enter the mixer. Then, the output signal from the mixer will enter the low pass filter to generate back the message signal. Now, I will explain about multi-level shift keying. For multi-level shift keying, more than one bits can be represented by a symbol. So what is symbol? A symbol is final signal representation before transmitted through physical medium. For example, amplitude, frequency, and phase. The formula for the symbol rate is equal to baud rate. Baud rate is the rate at which information is transferred in a communication channel. The symbol rate is also equal to bit rate over n, where n is number of bits per symbol. Bit rate is the number of bits that are processed per unit of time. As you can see here, symbol rate is also equal to bit rate over log 2m. In general, symbols required for n bits is m equal to 2 to the power of n. This technique is applicable to ASK, FSK, and PSK, but multi-level PSK has proven to be useful. Now I will explain about quadrature phase shift keying, or known as QPSK. QPSK is a form of PSK in which two bits are modulated at once. As you can see here, when bits is 00, the carrier signal will not undergo any phase shift. However, when bits is equal to 10, the carrier signal will shifted to 180 degree. And when bits is equal to 01, the carrier signal will shifted to 90 degree. And when the bits is equal to 11, the carrier signal will be shifted 270 degree. As you can see here, in this slide, QPSK also can be represented in gray code. If D bit is 11, the phase is 45 degree. If D bit is 01, the phase is 135 degree. If D bit is 00, the phase is 225 degree. And if the D bit is 10, the phase is 315 degree. Next, QPSK is better than PSK because of the efficiency in the frequency spectrum. QPSK is equal to 2 bits per second BPS over Hertz. For this slide, I will explain about how to generate QPSK signal. First, the event data from digital data will enter this BPSKI channel. In this channel, event data and carrier signal will enter this mixer. For the odd data will enter the BPSKQ channel. And same as before, the odd data and carrier signal will enter the mixer. However, the difference between this BPSK is this carrier signal is in cosine form, whereas for this, the carrier signal is in sine form. Then, the output signal from both mixer will be added, and the output signal from this junction will enter the band pass filter to generate QPSK signal. Next, to demodulate QPSK signal, the QPSK signal have to enter the band pass filter. The output signal from the band pass filter will enter the power splitter. From the power splitter, two signal will be produced, which is I signal and Q signal. For the I signal will enter the I channel, where the I signal will be mixed with carrier signal in cosine form, and the output from the mixer will enter the low pass filter, and the output signal from the low pass filter will enter the voltage comparator. Whereas for the Q signal will enter the Q channel. The Q signal will be mixed with carrier signal in sine form, and the output from the mixer will enter the low pass filter, and the output from the low pass filter will enter the voltage comparator. The advantages of digital radio modulation is first, efficient use of spectrum space. Second, increased amounts of information that can be passed down a single channel. And third, improve audio clarity at low receiver signal levels approaching sensitivity. Now, we will watch a guidance video of the Mission 4 of Ericsson Educate Tech Traveler game. This QR code will take you directly to the game. Now, you may scan the QR code to participate. Thank you from us and enjoy the game.